In a closed packed structure of oxides, 1/8 of the tetrahedral voids is occupied by bivalent cations and half of the octahedral voids are occupied by trivalent cations. Calculate the molecular formula of oxide. How will you calculate the molecular formula of oxide? See, there is closed packed structure of oxides. Now I have told you that the ions or the ion which is bigger in size forms the closed packing, right? Whereas the smaller ion slips into the void. So the bigger ion is forming the closed packing, whereas the smaller ion slips into the void, right? Now, of anion and cation, which is the bigger one? The anion. So here we have got a bivalent cation as well as a trivalent cation, and we have got an oxide. It means the oxide ions are forming the closed packed structure. That is like this. Say if I have got this cube, so there are all the oxide ions. See this, right? And at the center where there is the voids are the formed. These are the voids, right? So in the voids, what are present? The cations and the anions. Now, for one sphere, there are 2 tetrahedral voids, right? That is, for one oxygen, there are how many tetrahedral voids? 2. Right? So, what is it? 1/8 in a closed packed structure of oxides, 1/8 of the tetrahedral voids is occupied by bivalent cations. It means the bivalent cations are occupying 1/8 of the 2 tetrahedral voids for one oxide. So that is, it comes out to be 1/4, right? And half of the octahedral voids are occupied by trivalent cations. So for one oxide, how many octahedral voids are there? There is one octahedral void, right? So it is half of the octahedral void is occupied. So be the trivalent cation, it is 1/2. So it is 1/2. Now what will be the formula? There is 1/4A, there is 1/2B, and there is 1O. How can you do this? Just multiply the whole formula by 4. That is the numbers by 4. So that it becomes 4/4, B 4/2, and O 4. So it will give you AB2O4. So the formula of the compound would be AB2O4. Right? Did you get this question? You have to just remember that for one ion or one sphere there are two tetrahedral voids and there is one octahedral void. That's it. And you can solve the question like this. Right?